Okay, what were you gonna say?
Just an intro, and then I will stop my video, but keep my voice.
Okay.
All right. You ready to start?
Yeah. Is it time yet? Do we give him a minute?
Yeah, we still have a minute. But all right. Hello, everyone. You're in room 3, and we're about to hear about "Stop Getting Got" by Git, presented by McKay, Salisbury. If you have any questions, please ask them in the box next to the video or in Slack room 3, and we're about to hear about "Stop Getting Got" by Git, presented by
Hello, my name is McKay Salisbury. I am a principal software engineer at Dave. They're a Los Angeles-based company, but with new work from home options. I'm currently working in Utah. Grew up in Utah, went to school here, family's here, and why pay rent in California if I can get a lot more space here in Utah? So Dave is a financial services company. We focus on banking for the underbanked, try to be non-predatory and disrupt the current banking structure as much as we can and help people grow their financial independence. So today I'm going to be talking about Git. It's an intermediate talk about Git. The agenda, we're going to talk about what Git is, what the graph it uses underneath, and how to best visualize what's going on in Git. We're going to talk about what branches are. We're going to mention some specific Git work, we're going to talk about Git workflows in general for just a little bit, and then we're going to talk about the Git timeline workflow, which I think is a great system for using Git for a lot of different types of teams. But this isn't going to cover everything. We're not going to be covering what I would call basic Git things. If you don't know how to use Git at all, if you've never heard of it, this might not be the best talk for you. We're going to get in a little bit deeper than that. But also, we're not going to be covering super advanced topics like what's in the Git folder and how it stores its data under the covers and how you can hack in Git and build your own plugins. We're trying to do something that will be helpful for those who already know how to use Git a little bit, but not super advanced topics. Also, I was talking to a friend of mine. Hey, I'm presenting on Git. And he's like, "Are you going to teach about the GitHub?" No. I don't know the GitHub. I heard this song recently. If this is what you're here to do, I can't help you with the moves for this song either. Sorry. So first we're going to talk about how Git was designed and how it's a distributed server. And we're going to talk about what it is and how you can really think about what's going on. A lot of what we need to talk about first is terminology, because a lot of the words that I'm going to say will matter as to how things work. And so words have meaning. Let's make sure we're on the right page first. Over here on the right, we have the remotes. When you're interfacing with Git as to storing your source control system, you're going to be interfacing almost certainly with some remote of some sort. Most of the time, this is a centralized repository like GitHub or Bitbucket. I'm gonna talk a lot about GitHub today because it's a little bit more popular than Bitbucket, but the principles here, mostly I'm talking about Git, and it's underlying for a lot of what Bitbucket and GitHub are using. So the remote represents where the repository is that you're getting your code from, and so with Git remotes, first thing you're going to do is you're probably going to clone the repository, but it's more or less the same kind of a thing that happens when you pull or when you fetch from the repository. All of the data that's on that remote server gets pulled onto your own computer into what's called your repository. It's a local database of it's effectively, it could be a remote for someone else, but it's a copy of the entire repository and all the changes that have happened on your own repository. When you clone, it also pulls all of those changes into your local workspace, and you can change what's in your workspace to go to a different position in the repository by doing a checkout. But when you do a pull, it also does those different types of things to pull the changes into your local workspace. And then you've got your own folder, and you can just continue to work, and you're working off of effectively your own copy, and you can make some changes just like you would in regular Git. And just like in your regular IDE or whatever tools that you're using, You make some changes to your workspace. Maybe you've got some things that you'd like to get committed. And so you add them first to your index. Sometimes you do a commit -a, which will auto add in some cases. But when you add, it adds to an index, which is kind of a temporary holding ground before it gets actually committed to the repository. And then from the repository, you can commit to, you can push to a remote, and then whoever has access to that remote can also get access to whatever changes that you've made. So this is the general flow. I may be reusing some of these terminology, but just understand a little bit what's going on. We've got the remotes, and then there's some other things on your computer. And so Git was designed to be a very decentralized system. You can treat your repository as a remote for someone else. And so you can pull from your neighbor's computer, somebody who lives across the country, whatever. The code is everywhere. And so if one server goes down, if GitHub totally got nuked today, my team that uses GitHub wouldn't be affected at all. We wouldn't really lose any code because everyone shares the repository with everyone else. And so we wouldn't lose very much. And having that decentralization is very powerful. But also because everything is on your own machine, the actions are very fast. When you want to do a diff, you don't have to go and make a request to the server because all of the information is on your own machine. So a diff action and a merge action, these can all be performed very quickly. And you don't actually need a decentralized repository. I've worked with some teams where we don't need a repository. I'm going to pull from you, you can pull from me, and we'll just push to a remote server whenever we need to do that. It's not as common these days because GitHub and tools like GitHub and Bitbucket are very popular. And so we're centralizing in many cases, but we don't necessarily need to be. But one advantage that GitHub really does give us is there's a lot of advanced tooling. The ancestral compare tool in GitHub is much better than one built into Git. You can get some other tools locally if you want to use some advanced ancestral compare, and so that's cool. But it's pretty nice to have those tools available on Git. So as you're doing the pull request, you can see some advanced diffing options. It also has hooks built so that you can build into continuous integration, continuous deployment pipelines, so that you can, whenever I push to a specific branch, some tool, maybe Jenkins, maybe Circle CI, will take a look at your code and pass that on to the server, do some compilation, run some tests, and then push that to the server. And so you can deploy through using Git, and that's pretty cool and pretty powerful. It also has a tool that's called Network that I really, really love. And we're going to talk about that in more details. This is what the network page looks like on GitHub. So if you go to GitHub, you can click on the Insights tab. It doesn't look like a tab anymore, but it used to. And then there's a network option, and you can see what the graph looks like. This is from an open source project, but you can see they've got a main branch and they've got a bunch of other branches, and different developers are working on maybe half of these, maybe some of these are old, but I would guess a bunch of these are PRs that are going to get pulled through. But from here, you can learn a lot, and you can see where the history is coming. And so I use this network, the network tool a lot. And one thing that's weird is, why is it called a network? And so that's what I'm going to talk about next. But in order to do that, we need to talk about a couple of background types of things. Git stores its data underneath as directed acyclic graphs. And so we're going to talk about that in a little bit more detail. If I'm going over some of these things too fast, feel free to ask questions, reach out. I'm happy to stop and talk about whatever. So first, we're going to do a little bit of math topic. And please don't leave. The math here is going to be really simple. If you're scared of math, this isn't anything to be scared of. Maybe you guys remember from like elementary school or something, you see this picture here and you're like, okay, how do you draw this without going over the same line twice? This is an example of a graph theory puzzle. And that is about as advanced as of graph theory as we're really going to get into today. We're not even going to talk about the solution to this problem. But graph theorists might see this problem and might say, okay, well, let's analyze this in a bit more detail. And they might make a graph that looks like this. We've got 5 different nodes. Those are what the circles represent. And so each node represents like a stopping place in that in where you're supposed to draw. And there's edges that connect the nodes. So this is an introduction to graph theory. In graphs, they have edges and nodes. And we're not talking about like Cartesian graphs where you're plotting coordinates on the XY plane. No, this is graph theory type of graphs. This graph that we've talked about is an undirected graph. There's nothing that says that you have to go one way or another way, but some graphs are directed. Let's pull up this graph here. This is this has 5 different nodes and 10 different edges. Is it 10? Yeah, 10 different edges. And each edge has a direction, which means that you can't go both ways. You can only go one direction. This is called a directed graph. This is a specific directed graph for rock, paper, scissors, lizard, Spock. Paper covers rock, rock crushes scissors, scissors decapitates lizard, lizard crushes Spock, whatever. So if you want to play rock, paper, scissors, lizard, Spock, you kind of need to have this graph, this network in your head. And this is a cyclic graph, but some graphs are acyclic, most notably trees. And so a tree is kind of like maybe a genealogy tree, or when you're looking back to your ancestors, you can see all of your family trees, and that just goes up. It's not possible for somebody, one property of a tree is it's not possible for a tree to have cycles. And so trees are connected in that each piece is connected to each of the other pieces, and they're acyclic. And there's always only one path to get from point A to point H. Those are the general properties of a tree. We're going to talk about, but we're going to go into a little bit more detail about trees in a minute. But those are the 3 properties of a tree. But a network, backing out from trees, a network is a special type of a graph. It's a graph where you've added data. When I think of networks, you could think of this rock, paper, scissors, lizard graph thing as a network. Yeah, sure, there's the 5 different edges and how they're connected, but each of these nodes and edges have meaning. When I play scissors, it cuts paper. That means something. It's not just some abstract math concept that mathematicians may be running algorithms on, but the network means something to us as humans. But when I think of a network, I usually think of computer networks, how all the different computers are connected to switches, connected to hubs and routers and servers and firewalls, and that's a very common network. This is what I think of the most when I think of network. But we also have things like the social network, which is also very common types of things when we think of networks. When I think of, I've got a friend named Jeff and I've got a friend named Trevor, and they don't know each other, so they're not connected, but Jeff and Trevor are both connected to me. Those are nodes and those are edges, and we can talk about the social network of the friends of friends of friends, and how people are connected to everyone across the world theoretically through all the different connections they have. But these connections have meaning, and so they're a network. What brings us back to bringing us back to Git. Git uses directed acyclic graphs. They're not trees because there's more than one path to get back to where you came from. Each commit has a reference to its parent, or its multiple parents, as in the case of a merge. When you make a commit, you reference it, hey, these are the changes that I'm making from a previous version. And underneath it, the way it stores is kind of irrelevant, but what we really need to know is the differences between point A and point B. And so that's really what you're storing in most cases for the commits. And you're also storing who your parents are. I think GitHub draws the arrows the wrong way because the parents don't have any references to the children, but the children do have references to the parent in the way Git works. So I don't like the way the arrows are drawn, but that's not really relevant. But because the parents are in the past and you can't have, your parent can't be one of your children or even one of your great-grandchildren or whatever. So it's impossible to have a cycle in the Git graph. And with this information, we could create a partial ordering, and they usually create a full ordering with the timestamp with the timestamp. But Git uses directed acyclic graphs. So bringing us back to this network page in the GitHub interface from Insights and Network, it is a network. I always think of this as the graph underneath, but it really is a network because there is a lot of data to it. So this network information can be very helpful and can be very valuable in figuring out what's going on in your tree.
You are technically correct. The best kind of correct.
So next we're going to talk about branches. And branches are something that we talk about a lot when we're using Git and GitHub and other tools. And I think the term is used incorrectly a lot, and we think of it incorrectly a lot. So if this is a sample image, we can see, oh look, somebody has a branch named feature Java 11, and looks like they've made 7 commits since they recently pulled off whatever that blue line is. And we tend to think a lot as in the industry as all of those green things are the branch, but that's not really true. What we need to remember is that a branch in Git is really just the label. It's that little black arrow, the little black oval that has a pointer to a specific SHA. There's nothing, there isn't an extra copy of the code or anything. A branch is just a reference to an individual node in the graph, which is really just the commit, the SHA, one point in time in the repository. It's a copy of the code somewhere. And we tend to think of a branch incorrectly as all of the things since they broke off, but that can be damaging, and we'll get into a little bit more detail a bit later about why that is. So why are they called branches then? When we're talking about a mental model for Git, mental models for Git, we should be thinking about it as a graph or as a network. But remember, they are not trees. And when we think of branches, we think of trees. So why is that? Well, that's because of old source control models where they had a version tree and then there was a trunk and then people made changes off of that. And if you used source control tools in the 90s, it made a little bit more sense. And the terminology has mostly stuck since then. And it's kind of problematic. And the branch model came from that. But remember that it's not really, that they shouldn't really be thought of as branches because Git doesn't really use trees, because trees don't normally grow like this. They don't normally merge back together after they've split off from the ground or something. So the tree is a flawed mental model. And so I use flawed pictures of trees to help you remember that. Sometimes things can be a little bit prettier. And if you're working really hard, you can make your things that grow back together pretty, but it doesn't mean it's a mathematical tree. Sure, it's a tree though. So next we're going to talk about Git workflows. As whatever team you're working on, you probably have a workflow that you use, but you may not have it codified. What are the rules for when I want to do a hotfix? How does that really work? And if you don't really know the answers to those questions, if you're just going to guess, if your team hasn't talked about it, then you really need to spend some time thinking about a Git workflow. So get a Git workflow, unify your team. I'm going to talk about two workflows today, one I don't like and one that I like. I don't really care which one you pick. If you pick any workflow, you'll be better off as a company if you have a workflow and you stick to it and you publicize it and you talk about what that workflow is, because then people will understand what to do and you'll have far fewer problems when things won't go bad as often. And when they do go bad, it'll be easier to find out what's wrong and you'll be able to figure out what's going on better. So the first one I'm going to talk about is the Gitflow workflow. It's a very popular workflow. It's kind of the default everyone uses. Everyone uses some variant of this if they don't really know what's going on, partially because the tools for GitHub make this very easy. But there's a couple of flaws with it, and I'll talk about why I don't like it, but not until we understand what it is first. This is the prototypical image that they used to share. I think he's got a newer version. I've been using this one in my slides for a while. But this is what you should be thinking about if you're using the Gitflow workflow. Each different branch has what they're calling a branch. They think of as like they've got these lanes that things swim in. So up in the top left-hand corner, we've got the master branch. The master has had 4 commits on it. There's probably 4 separate commits to production. They're tagging each release. Whatever I'm saying here has nothing to do with tags. Use tags for every time you deploy. I think that's a great system. You may want to keep track of historical versions. We're not going to talk about tags because they're not really relevant to what we need to be talking about, but that doesn't mean you shouldn't use tags because I'm not going to talk about them anymore. So we've got the master flow and different commits have been made to the master flow, but that's not where most of the work happens. Most of the work happens down here in the develop branch. We've branched off of master. We've got some changes that we've made, and developers keep making changes. Usually changes happen through pull requests where a developer starts working on his own thing. When this developer's finished, they'll check in, get their pull request finished, and that'll get merged back into develop. So develop becomes the primary working point for most users. They'll check out from develop, make a branch, make their own changes, pull request them in. Sometimes they may be short, sometimes they may be very long. And when it comes time to be ready to deploy, we're going to create a release branch for that. We're going to say, hey, look, this is the branch we're working on. Let's take a look and see if we like it. Oh, nope, we found some bugs. Let's fix a couple of the bugs. When we're finally ready to deploy, we'll push that to prod and deploy to the master branch. And that's great. One thing you need to remember is that these commits here are very important. Whenever you've made a fix in the release branch, you need to merge that change into develop, because you want those fixes, because we found some bugs as we were trying to deploy to staging. Those things need to be fixed. Sometimes you find a bug in prod, and that's a problem. The users are experiencing something, we need to fix it immediately. We've maybe made these 3 or 4 changes and we don't have time to test and deploy those yet, but we have something we really need to fix. It's a crucial issue. We're losing money as a company. Great. So you create a hotfix branch, you fix the change that you need to do, and then you merge that back into master. And while that works well, it's very, very, very important that this fix gets pulled into develop. This is a very important commit that needs to be done, because if you don't, the bug fix is in master and isn't in develop. And then when you're testing in develop, you're not going to be testing the same behavior that's in prod. So whenever you fix something in master, whenever you push something to master, you have to pull this to develop. And so this is, in a nutshell, the Gitflow workflow. Feel free to use it. If you want to learn more about the Gitflow workflow, you can go to Vincent Driesen's page, and people have talked about it all over the internet. Look up the Gitflow workflow if you want more information. But I don't like it. And there's a few reasons why. Number one is it makes extra commits for everything. When you got to a point here with the release branch, we decided that this was good and this is great. We like this. Let's push it to the master branch. They create a new commit for it and they merge in what they had here with what was here before. And as long as all of the other changes that have ever been made into master are into here, we shouldn't have a problem. But sometimes we do, and it's really hard to tell that at first. So they create a new SHA. So that means you're pushing something that you haven't necessarily tested into production, which probably is going to be the same code, and you can really check. And if you're using Gitflow, I recommend that you do check to make sure it's the same, at least periodically. But it makes a new SHA, and I don't think that's a good thing because it can make changes. Also, it's hard, like I mentioned before, it's hard to know whether or not you've made a mistake. Did I pull in all of those changes into the master branch? Did I when I made the hotfix, did I pull those changes into develop? Because it's hard to see whether or not you have. And you can use diff tools to figure out whether or not they're working, but it's not very obvious to see when something does go wrong. Also, they have to reuse branches a bit. They've got this release branch. In this example here, this branch kind of dies. It goes to master and then to develop. And then how do you recreate this branch? Did they delete it and restart it? And even if branches were a swim lane, which remember in Git, they're not a swim lane, there's nothing associating this with this. So it's kind of hard and it's a bit weird. But the real problem is the graph doesn't look right. If I could make Git look like this when I was doing Gitflow, I would love Gitflow a lot more. But you can't do anything like this because GitHub doesn't know anything about the history of the branches, because Git doesn't store the history of the branches. So I went and made a repo that does exactly this. I followed all of these commits. I made the branches according to the Gitflow rules at all the different times, and I followed each of these commits. So every circle that you see in this is a commit that I made in a repo of my own. And it looks like this. So there are some swim lanes here if you look, but the swim lanes don't really line up. The black one does correspond with what we would call the swim lane for the master branch, and that's great. But what's that blue one? What does that represent? It's labeled release at the end, but release didn't have anything that looked that long in the original branch. The blue line is mostly develop until the very end. You can see develop gets pulled off into the bottom right. The develop swim lane is the blue until that last little yellow thing that comes off. The purple one does line up with one swim lane, more or less. The green and the yellows are just other weird things. Git doesn't have enough information to make the swim lanes look right. And so it's kind of hard to tell whether or not you've done everything right. Remember when I asked earlier, oh, that really important commit, did that commit get, the commit for the hotfix, did that get merged back into the develop branch? Well, it's kind of hard to trace and see, but yeah, if you look really closely, you can see, did that commit make it? Which one is it? Yep, there it is. That's the commit. It's kind of hard to see what's going on because it's lost in all of the noise. So if you want to use Gitflow, great. It's a decent system. There are tools that make it a little bit better, but know what you're working against so that you can figure out what the problems are. We have a question. Does one action put the changes into 2 places at once? No, I'm not aware of any tools that automatically push the things at once. There are probably some Gitflow specific tools that do something like that, but I'm not aware of any tools that once you've got a commit to hotfix that it pushes to both the master and the develop branch. But you could build something into your CI/CD pipeline with a button that does something like that if you wanted to. Good question, Jim. Thanks for asking. So the TLDR is why don't I like Gitflow? It's because the trees always look like this. I can't make sense of what's going on. Is that one tree or is that 3, 2? I don't know. This is what it makes hard to make. It's hard to make sense of what's going on with Gitflow graphs. So I present to you the timeline workflow. It's one that I've modified over the past, I don't know, 7 or 8 years as I've been working in software, as I've been more involved in the Git flows at my company, at my companies. Timeline has a lot of its terminology that comes from science fiction time travel movies. We talk about things that are in the future, in the past, and alternative histories. So from a high level perspective, from an overview, you want to have one branch for each environment that you deploy to. So some companies that's a staging branch and a production branch. Some companies that's that there's different layers in government bureaucracies. Sometimes you've got lots of different tiers of code that things need to get deployed to before they can make it to the right place, depending on how much bureaucracy you have. But another important thing is that we avoid merge commits, because merge commits complicate the tree and they make it harder to figure out when things are wrong. We say avoid, but it's not. We're not going to entirely eliminate them. But what that means is we're going to be squashing in our work, and environment branches will get fast forwarded. So if you understand everything in this, then in this slide, then that's really all you really need to understand with timeline. But the devil's in the details. So let's dig in. So step by step, we're going to create one branch for each of our environments. And at the beginning, maybe they're all going to be the same. And so this is what I like to call nirvana. We've got the prod branch and the staging branch and the develop, and they're all pointing to the same place. There's 3 separate branches, but there's really only one SHA that they're pointing to, because what was checked into develop has been checked into the staging branch and has also been pushed to prod. And this is great because all of our code is there. What the developers are developing against has been deployed to production. And if you have a continuous deployment strategy where you're deploying very quickly, we've deployed this, everything's good. Let's deploy to staging. Staging looks great. Let's put a prod. You can get to this a lot. But for some teams, especially in government bureaucracies or where there's even smaller amounts of bureaucracy, you're not going to get here very often. But this is the nirvana that we still strive for. Like nirvana, you may not ever get there, but strive for this. But it's okay if you don't get there very often. And some companies I work for, I never did, because staging had a 2-week process before that could ever get seen by the customers. So when a developer does new work, they made their 4 changes into their own branch. They make a new work branch, and then it's time to make a pull request. Whatever your pull request strategies are, that's great. The timeline workflow isn't going to interfere with what your requirements are. But when it comes time to merge, we need to decide, oh, let's get this work into the production. So, or it's got to get first into develop. So first, what we're going to do is we're going to merge, and I'm going to recommend the squash and merge option. We don't want to create a merge commit because that complicates the branch. It complicates the history, and rebase and merge would be even worse because then it puts all 4 of those changes into the branch in the history, and that's not good because as the developer made 4 changes, 3 of those were probably not good enough. So we want to keep those out of the history because it makes it harder to go back in time if we need to figure out what was wrong and get back to a good point. And those 3 are almost certainly a known bad point. So we may as well make that the default. You can go into your settings in GitHub and change your GitHub settings so that for the branch, we're only allowing squash merging. So after you've done the squash, it looks like this. Develop has moved forward. Those 4 changes in the new work got copied into the develop branch. And so now develop has a new SHA that develop got pushed forward to. And I like cleaning up the old branches, mostly to clean up the history. I don't really care. It cleans up this graph here, so we're going to remove them, but feel free to keep them if you like them. So as we next here, maybe 3 or 4 commits in, we've got a develop branch that is had some changes on it, and we need to push those to staging. So how do we do that? This is one of the things that I dislike the most about the timeline workflow, is that there isn't a great way to do that in GitHub, because GitHub doesn't have the tools for that, because every action in GitHub they want to create a new commit for, and we explicitly do not want a new commit. So we have to break down to the command line. This is the things that I've typed 100 times. I can do this in my sleep. Git checkout staging. We got to make sure that we're on the staging branch locally. Pull origin develop fast forward only. The fast forward only is to help us to make sure that we're not creating a new commit. If things go wrong, that line will fail, and you'll know that things didn't go right, which is good. Then you can push to staging that's been updated. And if you were pushing to prod from staging, you'd use a very similar command. But let's deploy to staging. And so now develop is caught up with staging, and prod is still in the past. It's still got his old code that hasn't been pushed through, but nevertheless, it's still in the past, and that's fine. We just need to keep track of where things are going. And if we decided to deploy to prod right now, we'd be in nirvana, and that's great. But that would be less interesting from the presentation perspective. So we're going to presume that didn't happen. Let's presume more work gets done in develop. This is what I call the iconic picture of timeline. We've got develop is where the developers are working. They're working against this particular branch, and maybe they have their own environment that they can break all the time. Staging might be considered the present because it's what most of the company is using, and prod is in the past, and we're trying to get prod into the present so that we can get things working. Maybe you're looking at it from the perspective of prod. From prod's perspective, staging and develop are things that we're going to get in the future, but we don't have those things yet. And this is where you are in most companies with any type of bureaucracy, where there's some work that hasn't been pushed to staging because staging is being vetted, and there's some work that's been pushed to staging that we're getting vetted to be pushed to prod. And this is where we're going to be, and you're going to be in some variant of this, usually with 50 or 60 branches going up to the side, but just ignore those for the purposes of what's going on. So sometimes there's a problem, though. We found a problem. Maybe it's in prod, maybe it's in staging. If you find a problem in develop, you're going to find problems in develop. That's the same thing as a feature. You're just going to make a new fix. And that's not really interesting from a workflow perspective. But what happens when there's a problem in prod, or when there's a problem in staging? How do we fix those types of problems? Well, easy. Depends on where we found the bug. If we found a bug in staging, we'll check out staging and make a fix, probably a hotfix branch there. If we found the problem in prod, maybe we're going to check out prod and fix it there. Or maybe we'll fix it in staging and push that to, maybe we'll fix it in staging even though we found it in prod, because we don't want to make a hotfix, we'll just put it out with the next staging employee. It's still kind of a hotfix to the staging branch because it's not going to go through the regular develop branch. So let's presume we're going to fix it in the staging branch first. So we're going to find staging, we're going to make a hotfix. We found the hotfix, that new change gets put on top of the staging branch because we want to get that out quickly and we don't want the things that are in develop to move forward. So if that's the case, we've got this hotfix branch, we find it, we test it, everything's great. Sometimes there might be two or three change sets in the hotfix branch, and that's cool too. And we're going to merge those into staging using the existing process or do a fast forward deploy. In either case, you're going to have staging that is now going to be off in its own world. Staging is not in develop's past, which is a little bit weird, but it looks wrong. And so when we see a graph like this, we think, oh, this means we know we have to do that thing. Remember how we said whenever we make changes to staging or prod, those changes have to get into develop? From the graph here, we can see, oh, look, develop is off in its own time stream, and we're going to have to fix that. But before we do that, we found this fix, we fixed it in staging, so let's push it to prod. So now prod, staging, and the hotfix branch, which doesn't really matter anymore because no one needs it anymore. It's just a label. We can throw that out anytime. So once those are deployed, we're good and we have the fix in prod. But we still have all these changes in develop and we want to get them out. How can we deploy? There's a problem here. The timeline has skewed. Somebody has gone into the past and made some changes. And in Back to the Future, that was a bit more of a problem. Same thing in Avengers Infinity War. If we go back in time and change the past, things can be problematic, but we need to have some Captain America who can go and merge things to make things, to bring things back to right. So we've got this alternate timeline. How do we fix that? Well, that's really easy. Go to develop, merge in prod. You can do this from a git pull prod, and you would do a merge, and it creates a new merge commit because we're merging whatever was in development with prod. And now we're done. There's nothing else that needs to be done. Prod and staging both have, prod and staging are now both in the past. And if we decided to merge, if we decided to try to deploy staging to get the new fixes that are developed, it's just the same fast forward merge as before. So because we've got this merge commit, the fast forward checks that we were doing will now pass. Everything's great. Timeline workflow, we can complete our time loop, become the Dot and the Jeremy Bearimy, whatever you want to do, or however you want to talk about it, we're clean. We now have that problem solved. So that's really about it. There's a couple of facts here, but I'm really much more interested in what your questions are and what kinds of things you guys have questions about for how timeline might fit into your organization. How can I help you? How can I help timeline fit for your organization? Do we have any questions? If there aren't any questions, I'm going to go over some of these questions kind of briefly. The first question is this for everyone? I think it's great for a lot of different types of things. If you have multiple versions that are maintained separately because you need to keep 6 things in separate isolated tracks and deploy fixes that don't necessarily need to get pulled into the same thing, that may not work for you. I think Windows used a very different type of a workflow. And if you have a team where you're supporting 6 different versions of old apps or something, this might not be the best fit. I don't think Gitflow is a better fit, but the Windows team uses a couple of good workflows for maintaining old versions, and feel free to look into them. I think it is a good system for red-blue deploys. You would have, instead of one master, you'd have a red master and a blue master, maybe call them red and blue, and you can fast forward them independently. Some people don't think it works as well if you're doing continuous integration and continuous deployment, where developers are making changes and those things are going to prod every day. I haven't worked in very many situations where things going to prod every day is a really good idea, but it happens every once in a while. But even still, I think Timeline is a good system. It's just not as mandatory. And Gitflow can work okay in those cases because you're deploying to prod very, very frequently, so that's less of a problem. Some people always ask, well, I really like how pull requests work. Why are you breaking down to the command line? If GitHub will still enforce all of your pull request rules, even on the command line. So if you want to say, you know what, we can't deploy to prod until we've had 5 people sign off on that, you can create a protected branch in GitHub, say, hey, the prod branch requires 5 people to approve the commits. You make the pull request from staging into master or into prod, and then you get your 5 pull requests. And until you do that, the command line commands won't work. So GitHub will still enforce all the pull request rules, and I think that that's great. Some people really dislike having a lot of branches. They feel like maintaining branches is difficult. And if you can just have one branch that represents all of those environments, then that works really well. But I think a lot of that concern comes from people who think branches have a lot of overhead. Branches are just a label, so who cares? Why not make a bunch of labels and have those labels mean something? Have specific labels. There's a problem in prod. Oh, well, let's go pull out the prod branch to see what's going on. There's a problem in the red deploy. I know where that one is. Let's go pull up the red and start making changes there. Like, what about rebases and resets? Should we be using those? Those are great tools, sometimes a bit more dangerous. If you want to have any questions about how those work, feel free to reach out, but that's mostly orthogonal to what's going on. You might, when I'm personally doing my development, I like using rebases on my own branches to keep my branch up to date, but that's not necessarily a great idea for everyone, and rebases can easily mess you up if you know what you're doing. So be careful with rebases and resets because you can lose some of your work, but it's usually not too bad. We don't have any more questions. I'm happy to reach out, but unless anyone has anything else to say, I'm kind of done. Thank you very much for coming. I'll be sticking around if anybody does have any questions. Thanks for playing. Jim has another question. I understand that there are multiple tools people use with Git. Which tool is the best? Does it depend on preference? I'm not sure what you mean by tools. If you're talking about like local development tools, or are you talking about like server hosting tools, Jim? I'm going to start answering both of those questions. Maybe you mean something different as best as I can. I use the command line tools for Git, and I don't install any other tools like Tortoise or dev shells. I use Visual Studio Code for some of my development, and that has a Git tool built in, but I don't use it for committing, mostly because I like the command line and I'm comfortable with that, and I know it's going to be the same at every company I go to work for. So, but if you like using a visual tool for helping you keep track of commits locally, feel free to do that. They're all going to be using the raw Git tools underneath, so they each have advantages if you'd like to use them. I don't like installing things, so I just use Git. But there's a lot of tools that are great for different types of things. For seeing, like I talked a lot about the network tool. You can get that type of an experience on your local machine much faster than what GitHub can do. And if you like that type of thing, there's a lot of tools that can do that for you. I don't use them personally. I can't necessarily recommend any, but feel free to do them. I don't think that's necessarily relevant to timeline specifically, but I'm happy to talk about that in more detail if you'd like. Maybe you're talking about server-side tools, though. With respect to server-side tools, the two most popular these days are GitHub and Bitbucket, although GitLab has since been gaining a bit more traction, especially since GitHub got bought by Microsoft and some people are anti-Microsoft and whatever. And so those are three different server-side tools. I haven't used GitLab, but as I understand it, they're trying to be as much like Git used to be, or GitHub used to be. So maybe use them if you like open source and you want to stick it to the Microsoft man. Great. Bitbucket was made by Atlassian, and Atlassian has a bunch of other tools. If you're using things like Jira and Confluence, GitLab or Bitbucket integrates with them just a little bit better. I mean, they can't ignore the GitHub in the room, so Jira and Confluence work pretty well with GitHub, so you can make that work. I used to use Bitbucket a lot back when I used Mercurial more than I used Git, but since Git has taken over and Bitbucket has even stopped support for Mercurial, my Bitbucket libraries have mostly gone the way of the dodo. I still have a couple there, I think. So I'm not familiar with their tools and which ones are really necessarily better. The past two corporations I've used have had licenses, either pro or on-site licenses for GitHub, and so GitHub has just been the standard that I've used for a while, and it's the most popular, but I can't necessarily say that it's the best. I hope that answers your question, Jim. Does it depend on preference? Maybe it does. I don't have strong preferences, so maybe one is better than another. Good question, Jim. Thanks for continuing to ask. I may as well make a plug here for Dave. If you're interested in working for Dave, we are hiring. If you want to work at a place where we actually make conscious decisions about what type of Gitflows, what type of workflows we use, and have people who actually understand what they're doing and want to make the code better and to not live in squalor, maybe come work for Dave. Check us out. We're a financial services company focusing on improving banking for mostly for the underbanked, but for everyone, help improve the financial lives and let's get rid of predatory practices from the common banking industry. An overdraft fee should not cost $75. A cup of coffee should never cost $80. Oh, I see old questions. I was apparently doing this wrong. Here's another question. Using a command line tool to do Git stuff seems like it is old school. I've been using a Git source tool for years. Command line seems to be going backwards. Yeah, if you want to use a GUI source control tool, great. I don't, Git is installed on computers by default these days, so I don't really have to think about it. And I don't like downloading new tools. If you want to use a Git source control to do your fast forwards, using a GUI source control tool, great. Somebody else asked me my favorite Git visualizers. My favorite Git visualizer is the network tool in GitHub, and I've already mentioned that. I use that one several times a day when I'm dealing with those types of things. I guess it's not every day because I don't usually have to deal with that. And sometimes when I'm on my own machine, I could download a tool, but git log -- graph does basically the same thing if I want a local tool. So good question, Trevor. On Git visualizers. Trevor, maybe you have a favorite Git visualizer tool that you'd like to share. Feel free to share. Jeffrey Altman says Gerrit for the win. Maybe Gerrit, Gerrit, is a Git tool of some sort. I'm not familiar with it.
There's a question on Slack by
Oh.
Kevin. He says, please break it down to bullet points to describe the timeline flow.
Okay, the timeline flow is basically, if I had to break it down to bullet points, it's this. One branch for each environment to deploy and avoid merge commits, which means new work gets squashed in and environment branches get fast forward when it's time to deploy. So if you're looking for the super succinct summary, that would be this. Is there more detail you'd like to have, Kevin? And Yai, you mentioned there's a Slack channel. I'm not sure where the Slack channel is. Are they pinging you directly, or is there something I should be listening to?
Yes, it is a Slack channel called BMDD-Room3. I'm not sure if you're in it. But...
I am now.
Okay, I will get you in.
Oh, he says he's not familiar with fast forwarding.
Yeah.
Maybe that's what his question is. So let's go to talk about fast forwarding here. So if we start at the iconic position here, we've got staging. If we consider staging the present, then develop is in the future and prod is in the past. So there's two different ways you might deploy from an iconic perspective, and both of those are mentioned in the bottom left-hand corner. And so when you're deploying with those, you're fast forwarding one branch to another. And so if you, like looking in the bottom left, if we wanted to deploy what is currently in staging to prod, then we would fast forward the prod branch to where staging is. And the way you do that is you check out the prod branch locally or wherever you want to get it done. But because we're using things like GitHub, you're almost always going to be starting locally. So you're going to git checkout prod so that you're looking at what prod is on your own machine, and your branch, more importantly, your branch is prod. So you're currently have prod checked out and your current branch is prod. So when you make a change, it updates prod. So then what we're going to do is we're going to pull the changes from staging into our current branch because we're in prod. So git pull origin staging would do that. And I do the --ff only to make sure that it doesn't create a new commit. If prod wasn't in staging's past, or from prod's perspective, if staging isn't in my future, then I can't do the pull because that's what the --ff only means. Because if I can't fast forward, then it won't let it. So if we were in this hotfix state and we were on develop and we tried in develop saying git pull origin staging to fast forward develop, that wouldn't work. If we were in staging and trying to fast forward to develop, that wouldn't work. So when we tried doing this deploy, it would fail because one isn't in the past of the other. And so if you left off the --ff only thing, then it would create a new merge commit to do the deployment. And in some cases, that's what you want to do. In some workflows, that's what you want to do. But I recommend against doing that. So whenever I do a pull on my machine, I'm always doing a --ff only to make sure that I'm fast forwarding, because if that's not the case, then I'm doing something wrong. And then sometimes I have to do polls in weird other cases, like when I'm doing a merge, but I'm almost always very conscious of that. So my commands are my fingers know that when I'm saying poll, I'm going to do a -ff only at the end, unless I'm being very conscious of that. So that's what I mean by that. That's what fast forwarding does, is it doesn't make a new merge commit, it just moves the position of the branch. I hope that answers your question. Who was that? Kevin, feel free to ask for another. Also in the Slack channel, we've got things like graph does not equal tree. Yes, the graphs are not trees. Some trees are graphs in the mathematical sense. Sometimes we call the source control tree in Git terminology, but that is not actually a mathematical tree. Jeffrey Altman talked about Gerrit a bit more. Gerrit is a code review tool developed to support Android development, an alternative to GitHub and Friends. So yeah, that might be a tool that you guys could. I haven't used Gerrit before. It says it's to support Android development. I don't know why you would want GitHub, and Git is very agnostic to what you're developing underneath. It doesn't care what your code is. So I'm not sure what kinds of tools you'd want to support Android development. Maybe it has like CI/CD things built in, which would be pretty cool for Android development. I'd like CI/CD to be more integrated into the GitHub environment than it is. Sometimes it's a bit annoying when you're using GitHub to see how the checks are doing, because you have to go to the other pages anyway. So it might be a great option for having CI/CD stuff for Android pipelines built in. Thanks for the link, Jeffrey. Gerrit isn't for developing Android apps. It was developed for managing the Git repositories used to build the Android platform. Oh, okay. It's the repo that the Android developers use. The managing. It's used by OpenStack. Okay. Looks like it's another tool, kind of like GitHub or GitLab or Bitbucket. Gonna dig in a little bit more into this now. Oh, it does serve Git. Huh, seems pretty bare bones, which might be pretty efficient. It's hard to understand what they're doing in 10 seconds. So thanks for the info, Jeffrey. I'll look into it in a bit more details later. Yeah, real-time discussions don't work as well. I don't know what the latency is on this. I just saw that you posted that. The Slack conversations might work a little bit better, but these aren't going to get recorded. So I don't have a good answer to that question, but I'm not in charge of this. So I just talk when they say to talk. I prefer a big conference room where people can shout out questions at any time. Sometimes it feels kind of lonely just standing here in my room trying to remember to stare at the camera because there's people on the other side of that camera, but I don't see them. Shout out your questions anytime, guys. Well, I guess I'm going to sign off. Wait, one more question. It's Jeffrey again. Lag is about 45 seconds for Slido. Pre-recorded. Yeah, pre-recorded conferences would be really hard because then you don't get any response at all, and it's not really doesn't have the conference feel of like being able to ask the presenter questions. And I guess that's okay if you want to make videos for YouTube. Yeah. Jim wants to know if there's a way to see others that are here, and is there a way to ask questions with his mic? I do not know how to ask questions with your mic. And I don't know how to see who's here. There are 82 people in the BMDD room 3 Slack room. So that might be one way to count. I'm not sure how many are in the Slido room. The moderator might know a little bit more about how to ask questions with the mic, but I don't think that's enabled because I think it's locked through playback through LoudSwarm. But I think Slack is instantaneous. So if you write that, I'll be able to be a bit quicker. Maybe I'll type it as I say it, which will make me say it a little bit slower, but at least I can respond. And Jim, if you'd like a way to ask questions, I'll stick around on the Slack channel after. Feel free to message me directly. I think I'm supposed to get off in a couple of minutes. And so with any latency with LoudSwarm, that's not going to work out too well. But I'll try to answer whatever questions you might have that are related. Feel free to ping me directly. Yeah, Jeffrey says we can start a Zoom session outside of LoudSwarm if anyone wants a face-to-face meeting. I'm not sure how Utah Geek Events wants to promote that type of a thing, but I'm happy to join a Zoom meeting, and that shouldn't be a problem. Maybe before it's too late, I will say that I'm going to start a Slack channel called Git. Maybe I'm allowed to do that. There we go. I was able to create a channel called Git. Feel free to join if you have any questions. We can talk there, and maybe we'll make another Zoom channel or something later. I think that's about all the time I have. I'm supposed to sign off. Again, my name is McKay Salisbury. If you do a search for McKay Salisbury, you'll be able to find me pretty easily. There's only one other McKay Salisbury, and he's McKay D Salisbury, and that's not me. McKay Salisbury, I'm all over the place. Feel free to ask, and you can find me. Thanks for playing.